After selecting the input with the bell reduction, the next step is introducing the floating bar mechanism. I will gather the necessary parts for the bell reductions and test their capabilities as soon as possible. This episode will cover the detailed design concept for the floating bar. Hi, welcome to Sulu Engineering. I'm David. My floating bar design includes several features to align the floating bar with the XY gantry, which is pre-aligned with the heated print bed. This alignment process ensures the most precise tool rack for tool changing and maintains every movement on the Z-axis during printing. Let me introduce these features in my design. The first is the bar itself. In the previous episode, someone suggested using the DIN rail instead of the 2020 profile. This design choice is not only efficient but also effective in reducing the weight, thereby putting less load on the steppers, which is a better choice for the bar. Its dimensions are also shorter in the Y direction, providing a more compact bar mechanism than the 2020 profile. The second feature of my design is the unique T-nut carriage inside the door frame. Instead of using linear rails, I used the I-180 materials from Eagles that I tested previously. Using the T-nut carriage inside the profile can reduce weight and save space if the material is suitable. The I-180 material is wear resistant and can be applied directly to the profile without lubricant, making it a good choice for a lightweight door. The shape of the carriage is designed to allow a slight angle for the bar mechanism to align with the XY gantry. However, it is constrained in the Y directions to ensure the proper distance to the gantry. The carriage connects to the junction of the floating bar. The floating bar contains an optical switch on each side. The optical switch is used to align with the XY gantry, and an object triggers the switch for alignment. I use a long M3 set screw as a pin to block the optical switch. To implement this, a hole needs to be added in the lower front idler parts, and a thread answer should be used to create threads for the set screw. This modification is less complex than recreating the entire front idler mechanism as an upgrade. In addition, the junctions are included with bell fixing components. The bell will function like the Z-axis on the printer. Two steppers operate independently and home individually to align the set screws on the XY gantry. The junctions are connected to the DIN rail and secured together. However, a challenge remains. How can I effectively manage the optical switch wires when the bar moves without interfering with the belts? If you have any ideas, please leave a comment below. I used screws to secure the docks, also known as tool holders, to the DIN rail instead of relying solely on the shape to fit the rail. This choice was made because the 3D printed parts need the extra strings provided by the screws. Thinner mechanisms like clips or slides will not hold up well on the DIN rail and could easily break during changing processes. Using screws also makes it easier to print the holding parts in a stable XY plane orientation. The two arms will be attached to the front part with the DIN rail sandwiched between them. This design eliminates the need for extra screws to join the two arms. Additionally, I've left a gap in the DIN rail groove to allow for better ventilation, which will help to improve the airflow for the preheated tool head hot end fans. To create spacers between the docks, at the suggestion of another person, I use tenons and screws to hold them in place. I discovered that the center slots of the DIN rail do not align with the holes on the docks. To address these issues, the spacers have additional thread insert holes and tenons to connect the docks, allowing for a more secure connections to the DIN rail. This results in the docks and spacers becoming a solid piece that is firmly attached to the DIN rail. These are the features I designed for the floating bar. With the composite, I'll test the T-nut carriage first to see how suitable the material is. Or you probably have better options for it. Leave a comment to share your thoughts. As always, moving forward.